Yeah, so I guess from Aaron's presentation, we got PPE and PPH. So I guess these two are the most important files. So the PPE and PPH are just the population of electron whole state at specific time. So I mean, each column corresponds to a specific time. So you have multiple columns. That means you have multiple timestamps. So I guess here, this is we have a for loop. Inside for loop, we have two components, which is also another for loop. So the first one is for the electron, and the second one is for the hole. So by using this for loop, we can get the accumulation of population of electron and holes at different times. Any question?
I have one. So the first line where the variable slice is added together, like slice equals slice plus PPE times exponential.
So I guess basically this is corresponding to this equation. So here we have delta functions, right? So practically we use Gaussian distribution. Here is just a Gaussian distribution. So it's like the same technique we computed the density of states.
So what's the similarity, what connection, and what is difference from procedure in computing density of states?
I guess for density of states, we use Lorentz, what was the name of that? For broadening, right?
But if you use Gaussian for density of states, what else is different?
What else is different?
Yeah, if you look on the equation, first line with equations. Yeah, here. So what should we change in this equation to convert it into density of states? And it is a question to anyone who took computational chemistry course. Because the equation for density of states is included into standard template of the report, and I think all of us were writing it a couple of times. So is there a term that should be removed to convert this equation completely into density of states?
The row?
Yes. So if you remove time-dependent population, then it will be literally the equation for density of states. And in the previous versions of the or seeds of this codes, when one was doing it for surface hopping methodology, this analog of this variable was called DOS-POP for density of states multiplied by population. And if you ever see presentation by Levi or Jabet or Professor Kilina, who practice surface hopping, you'll see if they show their technical details, there will be DOS-POP variable, which we call just distribution of energy versus time. Yeah, thank you, Yulun. Thank you for showing it.
Yeah.
Please continue. Sorry for interrupting.
I guess I need to add some details about the PPE. So basically, PPE is just a matrix. So the number of rows just corresponding to number of states for your system, and number of columns just corresponding to different time steps. And I guess from Aaron's presentations, we can convert the number of time steps into real times. So I guess that's the trick. So this S is our, I guess, results from the for loop. I guess later we will use this for the green figure.
Question. So it's a basic question, and it is not like exam to anyone. Let's just discuss and make understanding and agreement between each other. So what does this line S equals S slice mean? And I'm confident that you will be immediately answering, but anyone else wants to explain this line, especially those who never practiced it before, but maybe know MATLAB. So it's question to Amir and Kea and Boston. So it looks a little counterintuitive. Variable is equals to itself, and then oh, Sean is answering. Sean is giving a hypothesis that it is taking a picture at each one of these graphs. It's not wrong, and it's not the most precise answer. It's related, but here is not yet a picture. Like maybe if there are no answer from attendees, you may just describe.
So basically, you just put it together and for each time step. And I guess after many cycles, you have a cumulative file. So basically, the slice, in the slice you have prime, this is just to transpose the matrix. And then you put an S in front of it, means you put them together.
So
concatenate. Yeah.
So slice prime is the column, one-dimensional data, and S is a matrix. And each time this S equals S slice, each time this line is practiced, the matrix grow and getting one column more. So initially it's 1, then 2, then 3, and then it gets big matrix where each column corresponds to a certain time step. Amir, does it make sense? Kia, does it make sense?
It's like what we did in high school, the matrix, changing the matrix.
Okay, yeah, sorry for interrupting. You want to continue?
Yes, here we have a small script. I guess this is just to calculate the average. So like this is basically the black dashed line and also black solid. So at each time step, we will have a value. And then we just put them together into a VE file. And here is this block of data.
Can I add a comment? So suppose that at a given time there is a population of several orbitals at the simultaneously, and then someone wants to know what is the energy of electron, what is the energy of hole, or what is the energy of excitation. So if at each time there is only one orbital populated, then we will tell energy is equal to energy of this orbital. But if there are simultaneously populated several orbitals, we need to take an arithmetic mean value of them based on proportions, how much each of them is occupied. And this first 4 lines in the code here show this. The PPE apostrophe times energy of electrons. So this line includes summation over, so this column summation over all electronic orbitals. So this PP is a matrix, EE is a vector, and matrix by vector includes summation according to row by column rule. Okay.
Yeah, so this is basically the matrix multiplication, and you end up with a scalar.
Yeah.
So I guess this block of data just show the command for the green figure. I guess like nothing special. So
I have a technical question. What is hold on? Or anyone in the audience is, especially those who are new. And this is just basic question on MATLAB. So Samir, Sean, David, Kea, Amir, can you guess what is hold on command and why it is needed? And feel free to give some wild suggestions.
So you are talking about we have two different plots, so without any hold between them.
Yes. So Sean is asking, is typing, does it hold data?
Actually, hold the figures. We keep the same figures as a framework, so all the new data will be plotted on that same figure. So right now we have two different plot tree. So the second line will override the previous one. So maybe we will lose data and we need another hold on.
Exactly. So if one types several plotting commands one after another, they will erase previous one. And Aaron is typing here, it allows overlaying of multiple sets of data. And here one needs to overlay this greenish figure with yellow and blue stripe. So one set of data, then dashed line, second set of data, and continuous black line, third set of data. Right? Okay, Yulun, sorry for interrupting. Do you have anything else to add about this figure?
I guess not really for this one.
If someone is not happy with X or Y ranges, which line should be changed?
You have the access command.
Okay.
Then modify these numbers.
So first two are initial and final X, and last two are initial and final Y, right?
Actually, the first one and third one are for X. Second one and fourth one are for Y.
Let's check if it agrees with the figure.
I'm not sure.
Well, it doesn't agree with this figure, but I would, let's make a bet. I would vote for first and second for X and third and fourth for Y.
Yeah, I think you are right. I'm using a different format for doing that. Xlim and Ylim comment.
David was going to make a comment.
That is right. First and second are X. It's third and fourth are Y.
Okay. Yep.
So I'm happy I don't place my bet on that. So.
Okay. Okay. Yulun, sorry for interrupting. Please continue.
Yep. Okay. So next is hard carrier dynamics in space. So I guess pretty much similar kind of code, except the input is a little bit different. So previously we use the energy, but here we use, I guess, the bandout. This kind of information extracted from the bandout file. And I guess previously we used the EE, and here we have BE. So I guess that's a major difference. Another difference is, okay, for the hard carrier dynamic in space, we treat electron and hole separately. So I guess previously we have a single S field, but I guess this time we have WWPE and also which is for hole for electron, and also WWPH for hole. I guess the middle is just the same. It's also the Gaussian distribution. Any question on this one?
Yes. So line number 5, WPE. Yeah. What before this one. So what was wrong with it? Why next 10 lines are needed? Basically, this line and the second from the bottom, WPE and WWPE, show the same data. They show how the distribution in space changes over time. And here is one line, and below there are like 10 lines.
I guess here the PPE is the same as before, and then we multiply something. This means it's a PPE projected onto space. So what we are doing next is we kind of do the time evolution for each step. Yes.
Yep. Thank you. So I would say we are doing just image processing. It is there is nothing wrong scientifically, but the single WPE has rather small number of grid points. Like here it is 241, which is much not much but smaller than the resolution of most screens. And if you plot this WPE on modern screens, it will be rough image with empty white lines, which will be not visually appealing. And we simply make image processing similar to spline, covering the spaces between grid points due to this trick with Gaussian distribution. So if we would have electronic structure and orbitals computed with like 2000 grid points, then we wouldn't need it. But this one is this 10 lines are needed for making images easier to comprehend and analyze.
I have a question.
Mm-hmm.
That Z steps should be equal to number of columns of the bandouts, right? The first one.
Yes, I guess they are the same number, I guess. Mm-hmm. You can double check.
What should be the number of columns of the bandout files? It should be...
It's just a grid points, right? Number of rows, each row stands for one orbital.
Yes, but and what about each column in the bandout? I'm thinking about that curve file.
So bandout is a matrix where number of rows is number of active orbitals and number of columns is number of grid points along Z, right?
Yes.
And the number of grid points along Z in the bandout is the same as in the parcharge file. Parcharge is like a three-dimensional box with a certain number of grid points along X, Y, and Z. And it is defined by the size of the cell and precision parameter in VASP.
Where did we define that?
We do not define. VASP decides it based on our precision selection. Like if you want to control it, when we prepare in-car files, there is a tag precision, and we type precision equals low, precision equal medium, precision equal high.
Okay, so usually there is a default value if you don't set it up in the in-car file.
Right.
Okay, thank you. Thank you, Dr. Han.
So here is the actual code for this kind of figure. And not very positive about the first one. I guess what we are trying to do is we try to find some extremes, so we can control the quality of the figure. I guess the boundary of the figure. So the next is pretty similar to before. There's really nothing to talk about. But I guess if you guys have a question, you can ask.
I have a comment to the first line and third from the bottom line. So it just for visual interpretation, it would be good to assign green color to equilibrium when amount of charge equals to equilibrium distribution, and then orange would be to, excess of electrons, blue will be to lack of electrons. But since distributions of electrons and holes can be more or less localized, automatic plotting of these distributions will change the median line between maximum and minimum. And then the equilibrium distribution can be different color, like more bluish or more orange. And if you set up maximum ranges, same value to the top, same value to the bottom, then it makes green literally in the middle. So the third line from the bottom has this axis. First two corresponds to x, second to third from the bottom. Yep. And last two corresponds to z, minimal and maximal and z. So it's it's not a scientific thing. It's just to make definition of color codes more reasonable.
That makes sense.
I have just a funny comment about the last two lines, x label and y label. So A powered by lowercase o, maybe it's not equivalent to angstrom. I think there is a angstrom letter in the MATLAB. I have it. I can share with you later.
Oh, you can type it in the chat line.
I think you need to copy that directly from a file. It's just a character. Maybe it's not possible to type it from the simple keyboard. And also another point is that there is a preview setting in the MATLAB for the font size and the aspect ratio of the figure. So each user can define a default setting according to his or her preferences. For instance, having aspect ratio 5.5 to 8 and font size 30. Then you don't need every time to be worried about adjusting those values. I will make a few slides about that next time, and I will share with you. So if you are interested in using that default value,
yes, would be really helpful.
It may be helpful. Oh, sorry for interruption.
Yulun, is it the last slide or there are more?
No, this is the last one.
Okay, then please join me in thanking the speaker. So there was an intense discussion, but are there more questions typed or verbal?
I have a general question.
Please.
So again about that greenish figure. So we have some collaborators, a group, not at NDSU. So they are working on conjugated polymers. So the previous time that we share our results on the, for instance, ground state calculation or charge injection, so the results was clear for them. So absorption spectrum or influence of the charge injection on the band gap. So right now we are doing much more complex calculations, but if we want to show them to somebody out of the, for instance, DFT community or quantum mechanic, just some experimental groups, I'm not sure how we should interpret those results, or they are equivalent to which kind of calculation that they are doing in the experiment. Because they seems, yeah, scientifically, they seem pretty complex, but maybe for some experimental groups, they do not make sense, or how these results can help them to.
Of course, I have a big temptation to say it's their problem, not ours. But
That makes sense.
Aaron, would you like to comment on your experience of making connection between this sort of calculations and experiment? So which observables can be, so to say, solved or presented to experimentalists in the way that they will be interested and attracted to it?
I guess ones that can compare pretty well to the experiment are the solid and dashed lines in the green figures. The spectroscopists can measure that using fancy pump probe methods. And at least for, well, yeah, at least for the model I was working at, it seemed to agree with experiment somewhat. You just have to use a different way to visualize it to compare. Like you can, like if you wanted to compare like the decay curves, like you just have to plot them like on a normalized scale instead of the green figure scale. So there are ways to like extract data from the MATLAB and plot them against the experiment. The green figures are just, well, they're pretty to look at. So that's one reason to plot a lot of the data like that.
Aaron, would it be correct to say, to answer experimentalists, buy femtosecond laser and you will measure the same things?
In principle.
Okay. Yulun, would you like to correct discussion and add something? Because the question is very valid. So connection between this time resolved calculations and experiment.
Yeah, I guess in experiment there are just standard measurements like the time resolved spectroscopy. So basically they can just get the lifetime. And our results can, if we fit our green figure, we can compare the numerical values of lifetime. And also we can calculate the quantum yield, which is also experimental data available.
Okay, so spectral data on photoluminescence and lifetimes are directly comparable to experiment. Can you please comment on other forms of experiment? For example, if there are photovoltaic cells that look for power conversion efficiency for photocurrent, is there a way, at least hypothetical, to convert this data into such kind of experiments?
You mean the GV curve?
Hmm?
You mean the GV curve? Oh, what's the meaning of that curve?
Just I'm trying to read mind of Amir, and maybe he is looking into collaborating with engineers who design solar cells, and their observables relate to current that comes from our specific architecture of solar cell interface. So is there a way to connect this methodology of quantum excited state dynamics and something related to efficiency of solar cells, like based on your previous papers on interfaces, how you can...
You mean using the continuity equation?
Which
continuity equation to get the flux?
Okay, yeah, thank you. Amir, do you partially satisfied? Do you have enough to like Sean and David, what are you thinking?
Yeah, I get some idea, and for sure I will ask more questions in the future. Yeah, we can discuss it more. Thank you, Yulun. Aaron, thank you.
There was a question from Sean. Was the z values for Yulun's last figure psi functions? I was not clear on what they meant. Yulun, maybe you can briefly share and we'll discuss it. And David, please prepare to present soon and think how you can lay foundation to what was not covered yet. Please.
It's related, but not exactly. This is so the band is just your orbitals projected on the z-axis. So here is a accumulation of every orbitals at each instant of time.
Can I contribute?
Yes.
So, Sean, wave function is defined as on time and position. And this figure has two axes, time on x and position on z. But wave function is a third dimension, which is out of figure plane, right? And here we show not wave function, but wave function square or density. And we are subtracting density of corresponding to electrons and density corresponding to holes, each of which is positive. But when we subtract, there is a chance to get something negative. Also, if this two-dimensional projections look strange, maybe we can ask Yulun to stop sharing and Kia to start sharing her slides. Okay, would you please share your slide?
Okay, just give me 1 minute. Slide. Are you able to see?
Well, let's go to 12.
Just 1 minute. 12, yeah.
So, Sean, do you think this image is clear for you? You can type just yes or no. Okay, now let's assume we look on this image from the top. So higher values corresponds to orange, lower values or zero values corresponds to blue. And then we look on it as a two-dimensional map. Would it resolve your question? Please type yes or request more comments. Okay, yeah, thank you. Thank you for confirming. Are there more questions to Yulun? Questions 1, question 2, question 3. If no, please join me thanking